Good morning, folks. Welcome to this session on Azure SQL Database Serverless. My name is Ajay. I'm one of the group product managers for Azure SQL. So we own the entire family of Azure SQL in the cloud, whether it's managed instance, hyperscale, serverless, and SQL on virtual machines. So today I'll talk about Serverless, which is our latest and greatest member of the Azure SQL family. The workloads where it is suitable to use serverless, and also some understanding on how the billing works. So the main objectives of this session is to identify serverless scenarios. We have various deployment options in the cloud for Azure SQL, so it's really important you identify the scenarios where this works correctly, and then you will realize maximum cost and benefits. So those are the two main things I would like to present today and for you to take away. So just to level set in terms of Azure SQL, how many of you use Azure SQL already today? Okay, all of you use it. So this should be quick. So if we go left to right, SQL on virtual machines, this is IaaS. It's been there for many years. The biggest benefit is if you want to control everything inside the virtual machine, from the OS and SQL version to co-locating applications to if you have certain application dependencies, then you would pick SQL VMs. We have a session on this right after this, so please do attend that. We are investing a lot to make it a great experience for you. And then as you move towards the right, managed instances. So this is basically SQL Server as a fully managed instance. This has been available for more than a year now. And this is a fully managed PaaS platform, the same platform where the rest of Azure SQL is built on. You get all the automatic benefits like HA, DR, backups, updates, features, etc., and running always the greatest version of SQL. And you will use this when you cannot go to databases, which is single database as a service, where you get only one database, and then you get resources provisioned and guaranteed for that database. So basically, if you look at this slide from left to right, if you have to think where you want to go, it's the first decision you have to make is whether you want it to be managed by you or by Microsoft. So that'll help you decide which direction you go. And then if you're going to PaaS, you pick whether you want a full SQL Server instance, in which case you'll pick managed instance, or you will go to databases if you're building a new apps which are basically working against standalone databases and don't have instance level dependencies, for example, like link servers, cross database queries, replication, SQL agent, etc. So that's your initial points of decision matrix. And then once you decide that, we have multiple tiers which in each of these options, general purpose, business critical, and hyperscale, which has been available for a few months now. These tiers are next level decision, which is based on how much of compute and storage you want and IOPS, and it'll help you decide which of these tiers you pick. And the two of the newest ones, hyperscale, which is basically massive limitless scale, you must have heard it many times already, goes above 100 terabytes for storage and more than 80 cores in a single replica and up to 16 replicas. So it's for extreme scale workloads. And then serverless, which will be the rest of the session today, is the latest offering in general purpose tier, and it'll come later in hyperscale tier in the future. So this is basically for workloads which meet the patterns of serverless. So let's talk about serverless workload characteristics. When will you pick this? There are many different types of scenarios where you can pick serverless. For example, like line of business applications, which are very intermittent in nature. For example, if you have like an expense report or employee performance review, these things don't happen daily. Like it's not a 24/7 application. It happens maybe once or twice a year or on a monthly basis. Or if you have seasonal campaigns, like if you have a retail e-commerce website and you're doing like holiday promotions, new marketing campaigns where you need to provision just for that season, it's a good candidate. Other scenarios where customers would love it is like dev test environments where you don't want a 24/7 instance. You run when you only need it during regular business hours when you're writing code or running some test workloads, and then you want to basically the instance to auto shut down when it's not in use. So those are some of the scenarios where serverless will be an ideal fit. And this elaborates some of those details a little more, and which is basically the main thing is if your workload is unpredictable and intermittent, then serverless will be a good fit. And also for like DevOps, right? When you're writing a new application and you don't know how to size your instance, starting with serverless is a good thing because that way you're not spending too much money, but yet you're able to iterate and find out what is the right size for your work application before you go live. So that's a good use case for using serverless. What are the typical patterns serverless is good for? Again, just to recap, the workload has to be intermittent. If it is a continuously used instance, then serverless will turn out to be more expensive. The billing for serverless happens, some of the characteristics. The scaling of serverless happens automatically. So that's a big difference between other deployment tiers of Azure SQL, which is all provision. You pre-provision the instance, whether you pick managed instance or if you pick the hyperscale or the regular single database. You have to pick your compute size, and then even if you don't use it, you get charged for it because the billing for that is hourly at the highest tier you picked. Whereas, and there is no auto shutdown. So with serverless, it automatically scales. You define the parameters up front, and we will scale up and scale down within those parameters. And billing for rest of Azure SQL, it's per hour at the highest tier you were in that hour. Whereas in serverless case, the billing is per second of compute used. And when the server is not used, you're only billed for your database storage. The compute is released and no bill is that. And rest of the past characteristics of serverless is matches rest of Azure SQL. Things like backups and deployment, like service updates, new features, etc., are automatically managed by Microsoft. So you get all the same benefits that rest of the Azure SQL family gives you. I'll pause for a minute if you have any questions. If not, I'll proceed. Okay. So if you compare with existing offerings in this chart, you can see, let's say you provisioned a 16-core general purpose instance of Azure SQL, and you're not using all the 16 cores continuously, you are still billed for unused compute resources. So in a lot of cases where this may be not desirable because you don't want to pay when you're not using it, and if it's an intermittent workload, it'll turn out to be expensive. So and also sizing is a big factor. You always have to size for your peak workload, even though you may not be hitting the peak frequently enough. So this is basically becomes a trial and error exercise for most customers, and in most of them always bias towards over provisioning. Even on premises, that's the same case because you always provision for peak capacity since you don't want to run into outages or issues when there is no resources. So here's where serverless can help. So as I mentioned, the big difference, if you see in the chart, is if those up and down is the CPU usage, we will automatically keep track of the usage of the compute, and depending on the idle time you specify, I will show how it works in a demo shortly. We will basically pause the instance. You can see there in the chart where there is no usage. During that time, if it has passed your idle time, then we will turn off the compute and release it back, and we'll take a backup of your database before we do that. So that way, your database is still persisted, but your compute is freed up, and the service is basically now in a paused state, as we call it, and you're only billed for your storage. And the service automatically wakes up when there's a new connection request that comes to the service. And we'll look at the demo shortly. In terms of price-perf, we have some controls. You have some parameters like min vcores and max vcores and auto pause delay, which will impact your billing. So max vcores is a maximum compute of your instance, which is same as your provisioned compute. So you will not be billed up to the max compute. What it guarantees you is we will give you that compute for your workload if you need it. If you're using under the max compute, we will only bill you for whatever you use. And when the server is online, the minimum we'll bill is whatever the min vcores is. If it's entering into a paused state, then we will only bill, after it's paused, we will not bill for the compute anymore. So that's how billing works, and it's per second, so it's not per minute or per hour. So it's very granular billing, and you will save significant cost. I'll show you the actual number. It's like 3 or 4 decimal places out. Per second bill is like 70 to 1,000th of a dollar or something, so it's very small. How do you create a serverless database? Very straightforward. You can do it through Portal, PowerShell, whatever your favorite client tool of choice. You can migrate an existing single database to serverless. For example, if you already have single databases and you're seeing this intermittent usage pattern of your CPU, then some of these can be migrated to a serverless by just changing the service tier. You don't have to export and import the data. And from a working with the database perspective, nothing changes. The connection string stays the same as how you would use Azure SQL, and rest of the characteristics of the engine is the same SQL Server engine, which powers the rest of Azure SQL. So all the features that you're used to using will continue to work. So from an application perspective, it should be straightforward and seamless. So let me quickly show you how to create a serverless database and look at some of the characteristics. Okay, I'll start with PowerShell, and then I'll switch to the portal. So I'm setting a resource group where I'm going to create it. And then let me make it bigger. And then I've already created a logical server. So you can put the serverless database in the same logical server where you host your all other databases. If you want to have a fixed connection string, you can have hyperscale, serverless, and the regular SQL DB, all database in a single logical server because it's just a container. So that shouldn't work. So I've defined my connection properties, username, password, etc. And let's go and see what's running in this instance by running this query. So all I'm doing is get Azure SQL Database in that resource group and list all the database and their current state. So this will just take a few seconds, and as you can see, I have 3 user databases. 2 of them are paused, and 1 of them is online. So the way you know it's a serverless database is you will see for a regular database, you will not have this S in the name, so in the service tier. So in this case, it's general purpose, serverless, Gen 5 hardware. That's how you would interpret it. If it was a regular database, this S won't be there. It'll be just GP_Gen 5. 2 of the databases are paused and 1 is online. So I pre-created some of this to show you the different states in the interest of time. And let's go back here. So how do you create a new serverless database? So let me just say DB4. And you can use the same PowerShell commandlet, new AZ SQL database. All the properties stay the same. The only thing that's new is compute model, where you say it's serverless, and you have 3 new properties where you specify your min vcore, max vcore. So you're basically saying the smallest serverless compute I want is 0.5, half a core, and my database will not need more than 2 cores. So basically, we will scale up or down between these 2 when the database is online. When the database is offline, this basically doesn't matter. When will the database go offline? That's determined by this setting, auto pause delay in minutes. So here what I'm telling is in 360 minutes of idle time, so which is basically 6 hours. I can, since the last compute usage, if there are 6 minutes of 6 hours of idle time, then go ahead and release this compute. I don't need this. So this is really important where you understand your workload pattern, because if you give your idle time too short, then if you keep waking up very often, then serverless is not a good candidate because you'll be spending more on the compute. But if your workload is so intermittent that it runs once a month or something, then you're okay with having low idle time, because you know that even if it's paused and the computer is released, you will not need it for many hours or days in the future. So the lowest we can go for now is 60 minutes. I'll talk about the roadmap in the future. So that's all I have to do to create a serverless database. So I'll kick it off. Meanwhile, I will go to the portal and show you a couple of things on how to do it from here. So one of the things we have changed is a unified Azure SQL portal. So in the past, how many of you have created VMs, general purpose, hyperscale, managed instance? And it's always a struggle, even for us, to find an entry point. So the biggest effort we have done in the past few months is have a single entry point called Azure SQL. If you go to the search here and type Azure SQL, you will find it. And then you can favorite it, so that way you can click on that. So I have it right here in my favorites, as you can see. It'll bring you to this dashboard. And from here, you can create any SQL in the cloud. In the first slide, I showed you VMs, managed instances, hyperscale, general, all that stuff now can be done from right here. And if you want to know the choices, just click on each tile. It'll give you the details of what under each tile. So you don't have to go searching. So in our case, since we are creating serverless, I'll be in the single database, so which is serverless is offered here. I'll go ahead and hit create here. And put it in my existing resource group. Let's call it a new database. I'll put it using existing logical server. I don't want elastic pool. So the place where you define the different types of tiers is here in our compute and storage. So the default is general purpose. So I'll go here and click configure database. And then instead of provisioned, I pick serverless. And so see the difference here. I mean, I wanted you to pay attention to this dollars. So estimated cost per month for 2 course. This is provisioned compute. So it's going to be there for you whether you're using it or not once you create it. It's like on-premises. If you install a SQL Server license, if you use it or not, you have still paid for the license. So that's the same model for the general purpose non-provisioned compute. Now, if I click serverless, same thing, 2 course. Let's make it 2 course so that you have a good comparison. And you can see per vCourse second. So the total monthly bill was $400 something. Now it's $4. So it's 100x cheaper. That's because here we have not started using it. But once you start using, this number will vary. And again, if you use it continuously, it'll be more expensive than general purpose. So max and min vCore is basically where we will scale up and down automatically. This is the auto scaling part. Whereas in a general purpose, if you provisioned a 4 vCore instance and if you hit capacity, then you'll have to manually scale it. You'll have to set alerts to monitor CPU percentage. And if, let's say, it goes above 90%, then you'll have to kick off a update to a higher vCore, which is basically could cause some downtime. So in this case, whatever max vCore you set here, we guarantee that it will be available, and we will scale up and down within those limits. And min vCore, I can leave it at the minimum. And auto pause. So this is where it depends what is your idle time before we take out the compute. So the minimum we support today is 1 hour. In the future, we will provide you even lower limits. And then storage is basically what size of database you want for this. And then once I hit apply, it goes and creates the instance. So that's pretty much all I have to do. So now let me go back to here. You can see this instance finished creating and all the properties that we specified in terms of number of max cores, min cores, auto pause, delay, etc. And you can also switch between regular database and serverless by just going to the configure tab. So here's my existing serverless database. I can go to the configure tab and I can switch between serverless and provisioned. If one of them doesn't, you started with one but you realize that's not the right option, then you can go to the other one. So that's definitely an option. So now let me go back to the slides. Okay, so we saw how to create serverless database and all the different options through PowerShell and through the portal. Now let's talk about the second characteristics of serverless, which is automatic pause and resume. So this cycle shows the different states the serverless database can be in. So the first time you create, it goes to the online state, and then when your auto pause delay kicks in is basically when your idle time timer starts, right? So which idle time is measured when there are no user sessions connected to your database and the CPU usage is 0. That's when we'll start the idle time clock. And then once the time elapses to the 60 minutes, which is the one I specified, we will enter what's called pausing state. So during the pausing state, we will take a tail log backup of the database, we will detach the database from the compute, and then we will stop billing for the compute. And then basically the database moves into a pause state. And during the pause state, we will basically have the database will show in the state as paused, and you're only billed for storage at that point. And how do you wake up? So wake up is also automatic. When you receive a login request, the metadata for in step 2, along with the database, the metadata for that instance is also persisted. So when a new login request comes to the same connection, we will realize the database is in a paused state, and then we will basically spin up a new compute instance with the same parameters that you had specified in the first time, and then we will attach the database to that instance and then bring it online. So it will basically move from paused to resuming state. We will also start the billing because the compute is coming online, and then we'll bring it to, once it's online, then your application is basically ready to use. So let me quickly show you how this works in a demo. It can take a few seconds to resume, so hopefully it's not too long. Okay. So before I go there, so when we created the database, we started with certain set of min-max scores and autopause. You can always come and change it either in the portal or to the PowerShell by just using these set commands. You can change any of the properties of serverless database if what you started is not what you want. So now let's go ahead and look at the status of all the databases. So we have 2 paused, and then these 2 we created new, so they're just online. They will be online till the 1 hour elapses. And so we can try and resume one of these paused databases. So how do you do that? So let's go back here. So let's pick database 1 to be resumed. So all I have to do is send a connection request. So I create a SQL connection string with my server name, username, password, and then the connection will fail because there's no real instance behind. So it's important that you put it inside a try retry block so that it can keep trying till the service comes online. General best practices, even to handle failovers or outages, is to have your application connect in a retry logic. So I'm going to run this whole code starting from here. till here. So this is, I also have a timer, like a stopwatch, as you can see here. So we can see how long it takes to resume. Okay. So sorry, I didn't change the database. So I connected to DB4, which was already online, which is why it came in within the 1 second. So let's go back here. Okay. That'll be a record if the compute is created and database is attached that fast. Okay, so now you can see it's trying to connect to DB1, and just like any SQL server, if the SQL server is down, if you try to connect, your connection timeout will kick in if the service doesn't comes within the connection timeout. So this usually, I believe this will fail a couple of times because the service is still, basically what's happening now is we are creating a new VM, setting up all the properties, installing, restoring the backup. So a lot of work is happening. So this can take some while, which is why I put it in the retry logic. And you can see that it took, and it came in 35 seconds, so which is not bad. So basically in 35 seconds, we were able to bring a new compute online, bring the database online, and then connect to it. So just to make sure that we are really online, I have a sample query to look at server name and version, and let's see that I'm not lying here. So you can see I was able to connect to that database and then ran the server name and then the version. So this is how resume works. And now if I go to the portal and check this database, which was paused before, is now online. So that's the auto pause and resume in work. And now if I leave it like this idle, after 1 hour, this database will go back to sleeping state and we will detach things. So if you, for example, if I go to the other database, you can see that it is still paused, and you can also see there is no CPU bill. And if I go back in time, the last time it was used was November 2nd and 3rd. So, and here at the bottom also it says the database was paused at this time. So basically there is no usage. Now let's go back to the slide. The most important part, which everybody cares about, how does billing work for serverless? So it's basically bill of larger of CPU or memory. So one interesting fact here is when you create serverless or any Azure SQL, you only specify the compute and storage. You never specify memory. Memory ratio is fixed. So for every core, you get 5 to 6 gig of memory, depending on which hardware generation you pick. So for the purpose of billing, we have normalized memory to CPU units. So which is basically every 3 GB translates to 1 core. So every 3 GB of memory you pick. So the way the billing works is we'll take the per second bill, which is 0.00072 US dollars per second, and then how much of compute or memory you actually used. So we take your vCore used and your memory used and take the max of the two and then multiply it by the per second. That's your bill. And for storage, obviously how much of storage you specified, that's how your bill. So just to have some more clarity, this is how the bill will look. So as you can see on the top chart is a true serverless application, which is intermittent usage. So if you look at the bottom, here, so I used about 837 vCore seconds. That's the amount of time the compute was used. So you were billed for that. The CPU utilization was around 42% max. So your bill is basically 837 vCore seconds times the dollar amount per vCore second, and which basically comes to around 12 cents for an hour. The same size provisioned compute would have costed you $1 for that hour for the same workload. Now, if you ran the same workload continuously, but not just 1 hour, but for one day, then it is not a true serverless application. In this case, you can see we use around 87,000 vCore seconds. So your bill would have been $13 for the whole day, which is significantly higher. It's almost 50% of your provision compute for the whole day. There are cases, and if you go to a whole month, then it's very likely that your bill can be equal or higher than that. So that's how the billing works for this. And in terms of comparing other characteristics of provision compute and serverless, again, if you have continuous workload usage, definitely recommend going to databases or even elastic pools. So elastic pools also is kind of like a serverless model where you're sharing databases in a pool instead of one database, serverless database. So that also might be ideal for some scenarios. Whereas if you have completely unpredictable workloads, dev test scenarios where you want to get rid of the instance, then serverless is definitely ideal fit. The second big differentiator is scaling. As we saw, the scale can be automatic in case of serverless, whereas in provision compute, you have to know how the CPU usage is and then scale up or down your service tier. And the compute responsiveness is really important. As we saw in the demo, it took us around 35 seconds to bring up a new compute. If you cannot afford that downtime, if you want, when you run a query, if you want your compute to be ready and available, because the other characteristics of engine is still important, like when you attach a database, what happens? Things like recovery happens. So those things can come into make a big factor on how long it takes for a database to come online. Very similar comparison to when you fail over an instance to a second instance, where we have to basically attach, not in the always-on case, but like cluster case, you have to attach the database there and bring it online. So if you cannot afford that kind of downtime, then provision compute is a better target. And again, billing, the main difference for the provision compute, we bill per hour. On the highest tier, you're in that hour. And then for serverless, as we saw, it's per second billing. So just to recap that, serverless can be more expensive than general purpose if you're using it continuously and not for intermittent workloads. So let's quickly look at the billing dashboard. I believe we quickly had a view there, but okay, so I've been, in the last few days, I've been running some workload against this database to show how serverless works. So you can see on the main overview page for the serverless database, we have two charts. One on what CPU is being used. On the right side, what bill corresponding vCore seconds that is. So you can see that it supports synchronous scrolling. So as I scroll on the left, you'll see it scroll on the right. And you can see there's a lot of idleness here. So you can see in the first half of the chart, there is no usage. Then there's some workload running here and no usage workload here. So this is a good candidate because it's very intermittent usage. Other thing you will notice that when I'm scrolling here at the bottom, when the CPU usage is 0, and the app CPU build will also be 0 on the right. So which basically tells you that we are not billing this database at that time. However, when I come to the chart where there's some CPU being utilized, you can see that I had 27% usage, but at the same time my bill was 3.5K charge, and you can see the bars align here. You can also drill into any chart and look at by different granularity levels, like I can go back last 30 days and group it, let's say 15-minute intervals, and you can see patterns of how your database. So this will give you a good way to determine if serverless is a good fit. It'll give you a good understanding, because 1 month is a good time period for you to run all types of workloads, whether it's daily workloads, weekly batch, nightly batch, month-end processing. So you will have a good footprint of how this database is being used, and if you make a decision on is serverless really the right fit for this database. So And as you can see, in this case, it is of course a simulation, but there are some times where it's very heavy workload, sometimes it's very light, and there's a lot more idle time. So if you have at least 50% idle time, then serverless will be a good fit because your bill will be cheaper than general purpose. So that could be another decision factor from knowing when to use serverless. Any questions? Yeah. The question is this a candidate for a dev test if it's running all day but not run all night? It can be. When you say run all day, it also depends on how your usage is. If it is running at peak 100% all the time, but if it is still 50% less time than the whole day, like if it's less than 12 hours, then it'll be cheaper than your general purpose. Yeah, yeah. So if you have a baseline workload usage, that'll help you determine if you will save costs here. Yeah.
Do you have any visibility when the scaling happens? And so how many vCores were used at a certain moment of time?
So there are different performance counters. Here we are only showing the 2 ones, but you can add more metrics by coming here. There are tons of CPU counters. So basically all the stuff you want, you can add it from here and monitor all of them at the same time.
Right, but that doesn't show when it's scaled up or down for the vCores.
So the actual vCores. So since the billing is per second, it is very hard to tell you how much of the vCore was used unless it matches the 100% utilization.
So one more follow-up. So how often can it scale up and down? Can it scale up to like the max vCores for like 30 seconds and then scale back down?
So the scaling is more a logical concept. Whatever max score you specify, you're guaranteed to get that. The scaling is more of the usage. So if you're not using all the max scores, you're only billed for what you use.
Okay, so that means it's not doing a scaling like when we
No, it's not actually creating a bigger instance unless you started off with only 4 you started with, let's say, max vCore is 4, and later you came and said, no, I want max vCore is 16. That's a manual scaling operation.
So your database connections aren't killed like they are when you do it with provision.
Correct. If you specify the max score right correctly, then you're fine. Yeah. Okay. So from a roadmap perspective, I actually forgot to mention this. Serverless was announced as generally available in this conference. So it's ready to go for production workloads and definitely it'll be deployed. The main thing we are investing in is to provide more compute and memory choices so that you can run workloads which are more compute intensive or more memory intensive. Today we support 16 vCores. We're planning to add more compute. The other big thing we are looking at is some customers who want more granular auto pause. They don't want to wait for 1 hour. They want it like in minutes. So this is something we are exploring right now. And also time to restart the instance from auto pause. So these are some of the things that are in our roadmap, and look forward to hearing new updates in the next few weeks and months. And then in terms of content, a ton of content available. Feel free to grab the details from that link there at the bottom, and definitely leverage serverless. It's been a very well received, and in fact the growth for serverless that we are seeing since public preview, which was announced back at the Build conference, has been tremendous. A lot of customers who did not have this option before are now choosing serverless, and in fact migrating their databases from general purpose to serverless general purpose for workloads which don't need it 24/7. And then I have some more resources in the appendix. So some examples that I use in my demos on how to add retry logic so that you're trying when you're resuming, and best practices. So that's all I have, and feel free to evaluate this session and provide feedback. And I'm happy to stay here if you have any questions. We have about 5 minutes. Thank you.